Greetings, this is Jim Lindsay. This is a lesson over storage, and as you can see from the Blackboard screen in front of you, this material is presented in Chapter 3 of your textbook. I would like to, in this lesson, basically we're right here, you're watching this movie, and the PowerPoint slides I'm using for this presentation are right there if you would like to get them. In this movie, what I'd like to do is cover some really important foundational concepts about storage, as well as some specific items that are mentioned in the chapter. I'm not going to cover all of it. I'm not going to cover everything in the chapter in this lesson, this tutorial. I have some additional resources for you. As you scroll down this page, you'll see there are some additional links to some movies, and none of them are real long. You'll see, like this one especially is very short. But what these additional movies do is expound on some specifics of how specific things work. Like, for example, this one goes into the specifics of solid state drives or flash memory and how that works. And in the process, the guy who's giving the presentation, he talks about how a traditional hard drive works, and you see that. And I think the whole thing is like maybe 6 minutes. And so this one's maybe a minute, maybe a whole minute, and this one is a little news piece, so it's about 2 minutes, 3 minutes long. But all three of these are things that are mentioned in your text, and because they do such a good job with covering those there, I'm not going to cover them here. And what I'm going to do instead is concentrate on some other things that I'd like to spend some time talking with you about. So that's what we'll do. I'm going to switch over to PowerPoint, and we'll go from there. All right, we're back in PowerPoint, and as you can see from the pictures on your screen, these pictures are supposed to indicate to you that this presentation is going to be talking about storage. And so there's all sorts of different cases and cabinets and bureaus and things like that you would use to store things around your house or in your kitchen or in your office. And so that's what we'll be talking about. Now, the first thing I want to share with you is this graphic right here, and this is something I found in textbooks a while ago, and I've added to it. I think it's a really great picture, and if you can commit this thing to memory, I think you'd be really well served as you go forward with exams that have anything to do with storage. We could talk about the stuff that's on this slide for quite a while. We won't, but let me explain to you what you're looking at. And so this is basically what I refer to as the storage pyramid, and all different forms of storage are depicted in this picture for you. And remember, you can get this slide from Blackboard. When you go to Blackboard and download it, you can look at this, because if you're just looking at this on a computer screen, especially if it's not in the full screen mode, it's going to look really tiny. So get the slide and be looking at it. Let's start at the top of the pyramid. It's talking about a specific type of storage, and that's something called the register or registers, which are part of the central processing unit. You learned about those back in Chapter 2 when you learned about the system unit, and then specifically the central processing unit and all of its specific parts. The registers are a form of storage that are inside of the processor itself. When you move away from the processor on the motherboard, you get to something called cache, and there are different levels of cache, and they can go from L1, L2, L3, L4, and so on. And basically, as the number of the level increases, that tells you that you're getting further away from the processor in proximity. You're physically getting further away from the chip itself, that CPU. And what that cache does is it basically functions sort of like a register, and it's very fast memory or storage, and it's something that gives the processor just some place to store something very quickly. And sometimes cache is built right into the processor chip itself. So on top of the register, there's also some cache right there. So it's called onboard cache. And so When you're shopping for a computer, if you see mentions of cache, specifically like L1, L2, L3, L4 cache, that's what they're talking about. So these are all forms of cache memory, and they're very fast, very close to the processor itself. Now next we get to RAM, random access memory, and you saw RAM being installed and removed from the motherboard in the lessons for chapter 2 when you were talking, when you were learning about the motherboard. But RAM is just basically chip memory. It's flash memory. It's on the motherboard. It's pretty close to the processor, physically close to the processor, usually a couple of inches away from it, and it's connected by the bus. And it's the RAM is always closer to the processor than the hard drive, and the hard drive is mentioned right down here. RAM is faster than hard drives. Even if you have a solid state hard drive, RAM is always faster because it's closer. If you have a solid state hard drive, which is something you're learning about in this chapter, it's still going to be physically connected through cables and stuff like that. Maybe about, it's going to take about a foot worth of connections, whereas RAM's going to be like 2 inches away. And as you're sending the electricity back and forth between the components, it's just going to be a lot quicker to get to RAM than the hard drive. So that's what's at the top of the pyramid. This whole from RAM up is what we call primary storage. These are the primary, when you turn the computer on, these are the primary places that the processor wants to store things. All this stuff from where it says storage device types, and it has like ROM, the BIOS, removable drives, network storage, hard drives, all of this stuff right here is permanent storage. This is secondary storage, and this stuff, and you'll see there are some terms off here to the right. You see volatile for the primary storage, and you see non-volatile for this secondary storage. And those terms are really important. What that means is when the electricity is turned off, everything that is volatile is going to lose its data. So all this stuff from RAM up is volatile, and it's dependent upon electricity in order for it to be working. This non-volatile stuff, the secondary storage down here, these are all forms of storage that are permanent. And so if you wrote a research paper and you saved it to a USB thumb drive, you could put that thumb drive in your drawer, come back a year later, take out the thumb drive, put it in the computer, and it's still going to function, and your research paper is still going to be on it. So that's how you basically interpret what's on the components of this pyramid. As far as the input sources go, you can just basically, we can disregard that for this particular discussion, but that's just talking about different means of inputting stuff into a system. Now what I do want you to pay attention to, though, is over here on the left hand side of the screen where it talks about cost and speed and capacity. And you'll see the cost and speed is in dark blue, and basically as you go up the pyramid, the cost and speed gets higher. And as you come down the pyramid, the cost and the speed gets lower. So what that tells you is that a hard drive is cheaper per gigabyte, or cheaper per byte, and it's also slower than what you'd find in a register. Again, so the hard drive is cheaper because the cost is lower, cheaper per byte, and it's also much slower. When you're talking about the registers, for example, that's right in the processor. That's almost instant, immediate. Whereas on the hard drive, because it's so far away, the system has to send stuff all the way out through the cables and get it all the way back. Now, in contrast to that, you have something called capacity right here, which is in green. And as you go up the pyramid, the capacity gets smaller, whereas as you come down the pyramid, the capacity gets larger. So, and this is pretty easy to remember. A hard drive, you can get like a 1 terabyte hard drive, really cheaply, and that's a tremendous amount of data. But your registers are usually just very, very small. RAM, for example, you're usually buying RAM sticks in like a gigabyte, or if you have like a brand new system, you may be getting like 4 or 8 or 16 or 32 gigabytes of memory, whereas you're getting terabytes of storage on your hard drive. And so as you go up the pyramid, the size or capacity gets smaller, whereas you come down the pyramid, the size and capacity gets larger. So that's how you use this this diagram. I hope it's going to help you out. And again, those terms volatile and non-volatile, those are important terms. They basically describe primary and secondary storage and really help you to characterize those accurately. Okay, so and I went ahead and just I paused it and moved the volatile and non-volatile to where they're a little bit better aligned with secondary storage and primary storage here. So let's move on. The next point I wanted to cover with you is an idea that's introduced in your textbook, which I think is really helpful. It basically describes storage as storage things as storage systems, and it describes that each storage system basically has a storage device and a storage medium. And as an example for you, I have an external DVD drive that's attached to a laptop. Maybe you have something like this for your computer, but you'll see like the device itself, the storage device, is this hardware that would play a DVD, which is the medium, and together the two make the entire system. And so as you're reading in the textbook, as you're purchasing things, when you're looking at storage systems, realize that not every storage system has a built-in medium. There are things like CD players, DVD players, some like flash memory kind of things where you actually have to go out and get the medium to go into the device. On my laptop, for example, I have some like SD card readers that I have to have cards that I can pop in there if I want to take advantage of those slots there. So the device is there, but the medium is not, and the two together make up the system. And so that's a good concept that's introduced in your text that I want to make sure that we point that out to you. Okay, and the next concept I want to point out to you is basically one of how a storage system accesses data that it's using. And it can use random access or it can use sequential access. 99% of the things that you're going to use are going to be random. And a best example I can give you right here is just a regular hard drive. This is a picture of a traditional platter-based hard drive with its cover taken off. This is the reader arm, which basically swings back and forth across these platters, and it reads the data directly from the platters wherever. Let's say it's trying to you've created a spreadsheet, and the spreadsheet's stored, some of it's stored here and some of it's stored over here and some of it's stored over there. It goes and it goes directly to those spots and gets that spreadsheet very quickly. In contrast to that, I want you to think back to the days when maybe you were a kid and you were riding around in the car with your parents and they had like a cassette tape player. And maybe you've seen Guardians of the Galaxy, and the character, the main character in the Guardians of the Galaxy carries around his Walkman cassette tape player. That is sequential access, and you will find sequential backup tapes in business in just about every business you're going to go into, because it's really cheap and it's reliable. So tape is still used like crazy at many businesses for the data backup. And the way that I hope you'll understand, but the difference between random versus sequential is this. Think of like if this was your parents' car or van, you're riding around with mom and dad, and you like the first song and the last song on the tape, well, after you've listened to the first song, how do you get to the last song? Can you just push a button and boop, be right at the last song? No. You've got to fast forward through all those songs in the middle until you get to the last one, right? And so that's sequential. And when you have a computer system that's using this sequential access kind of a device, it takes longer to get your data. And so if you're ever having to restore things from backup, which will happen from time to time, that is not a quick and easy process. It's labor intensive and it's time consuming, but it is very, very cost effective. You can store gigabytes and gigabytes and gigabytes of data on magnetic tape very cheaply, and that's why people do it. So this whole concept of sequential versus random, 99% of the time as a user, you're going to be using random access devices like hard drives, but when you become a business owner or a supervisor, or if you get into IT as a profession, you're going to have to learn how to use these sequential devices to do those backups and occasionally get data from those backup devices. Okay, next what I want to do, the next part of the textbook goes into a discussion of hard drives, and that's where I'm going to defer to the video where the guy's talking, teaching you about the solid state drives and then the traditional platter based drives, and you'll see how those actually work and function. But there is one particular facet of hard drives that I do want to mention, and that's that you can have internal or external hard drives. The one that your machine runs off of is of course going to be internal, but if you're looking for ways to store additional data or to back data up, another good option is to go with an external hard drive. They're really inexpensive. I did some price checking just a couple of minutes ago, and 1 terabyte hard drives on Amazon.com were all running about $55. I keep 2 of these. I keep a terabyte drive here and a terabyte drive at my office, and I do my backups to those. And then what I'll do, I'll take the after I have a blue one and a black one, and I back up to the black one, and then once I've done every once in a while I'll get the blue one, and I'll copy everything on the blue one on the black one to the blue one. And so I've always got 2 copies, and I keep them in 2 different locations. So if something happens to, let's say there's a flood or something at Grice Hall, and my blue one gets damaged, well, I've got the black one with my data on it. Or if there's a fire someplace, I've got the other one in the other location. And so if you're trying to do backups for your personal machines, these external hard drives are really fast and they're very, very cheap. And so check those out. And they're small. They connect through USB. Anything you buy now is going to probably be USB 3, and if your computer is USB 3 compatible, you're going to get that backup done really fast. And so when we get to system software, I'll introduce you to some backup utility tools that are really great and very easy to use for backing up Windows machines, and I also have some recommendations for you if you're going to be trying to back up an Apple machine. So that's something that's mentioned in the book that I wanted to point out to you. If you don't have one of these external hard drives, I encourage you to think about getting one because they're very affordable and very helpful. Okay, our next point, the book starts then talking about optical disc after it covers the hard drives. And I have that video for you. I want you to watch the really short one that explains how an optical disc works. But there are some characteristics of optical discs that I want to make sure you hear. When you get an optical disc, and that could be a CD or a DVD or a Blu-ray DVD, those, when you purchase those, basically it could be like a read-only disc, and that'd be like if you went to Walmart and you bought a new Taylor Swift CD, or you bought Guardians of the Galaxy soundtrack or something. That music that you're going to listen to, that's already been burned onto it, and you're just going to read it. That's called a CD-ROM, ROM, read-only memory. And so that's one flavor of optical disc. Now there's another, which is a recordable disc, and it's basically where you'll see like CDRs or DVD-Rs, and that means that you can write to them once. And then you have some that are called rewritables, where you like CDRWs or DVD-RWs, and each of those is different. The rewritables in particular have the structure of those is pretty cool. If you investigate that, as you're going to learn from that video, the way that DVDs and CDs work is a laser basically is bouncing off the surface of those things to whether it's going into a pit or going into a flat surface on that disc, and that mandates whether the light reflecting off of it goes straight or bounces. And so with a rewritable DVD or CD, it's got a material in there in the substrate of it that basically can get heated up. And so if you write it once and you have several different pits in there or little holes, which would, let's say that represents the one state or the on state. If you're going to rewrite it and those need to be zero states or off states, they get heated up and that substrate kind of melts and goes back together and it gets flat again. And so because of that, those are slower to use. And so if you're looking for speed, if you want to have a very fast performance from your optical discs, and you're not going to be needing to rewrite those again, go with the write once ones, because they're cheaper and they're faster once you've written them. It's just, if you need to be able to rewrite to those though, get that RW type. So sometimes when people go shopping, they'll think, oh well, that one's a little bit more expensive, I'm going to buy it. They've got to be better. Well, no, not really. I mean, it's a different purpose, and so I want to make sure that you hear that. So there's a difference between the ROMs, the Rs, and the RWs. And then lastly, the size of the laser itself, and this is mentioned in that video, but the size of the laser that is used to burn the pits into CDs or DVDs gets smaller as you go from CD to DVD to Blu-ray. And you'll see that basically the size of the holes over here is really big. With a DVD, it's kind of medium sized, and with the Blu-ray, it's really tiny. The example I use in class with this is a lot of fun. This is where I wish we were in a classroom. Is I would have somebody come up. I would have three of you come up to the front of the class and we have a whiteboard up there, and I would give one of you a dry erase marker. I'd give one of you a fire extinguisher, and then I had four of you come up there. I have two of you use this huge floor fan that we have. It's about 6 feet tall, and the fan itself is about 3 feet in diameter. And I'd ask you to write your name on the board. And of course, the person with the dry erase marker, they can write their name very easily and quickly. But the person with the fire extinguisher, it's kind of heavy, and it's probably about as big around in diameter as about the size of your head. So they have to sit there and sort of wrestle with that and try and write, let's say your name is Tom. They're trying to write TOM with this big heavy fire extinguisher, 4 or 5 feet off the ground, and it gets a little bit difficult. And the two people with the floor fan, it's really hard because that thing weighs about 75 pounds. And so two people trying to wrestle that and maneuver it to write a name on a board gets really difficult. And so the size of the pencil matters. And so the little one, this basically represents the person with the dry erase marker. They could put everybody's name in the whole class on the whiteboard really easily in a really small space, whereas the people with the fire extinguisher could get a lot of names up there, and the two guys with the floor fan, they're going to get one or two names in their space, and that's about it. And so that's why Blu-ray discs can store so much more data than a regular CD, because the size of the platter itself is about the same, but you can get about 25 gigabytes worth of data on a Blu-ray disc, whereas you only get about 700 megabytes on on a CD. And that's the reason for that discrepancy in the size, is basically you got a lot smaller pencil over here with Blu-ray. So I just think that's interesting, and I wanted to point that out to you. Okay, we're to our last couple of ideas here that I want to share with you, and basically I wanted to speak with you about network storage and cloud storage. These are really important concepts. This is growing and growing and growing. The cloud storage in particular is becoming the norm. You need to have a command of this whole concept, because when you get to your workplace, the old guys like me are going to look at you and say, well, you just came out of college, you should know all this. This whole cloud storage thing should be something that you're really comfortable with, or at least understand. Here's what we're talking about. With network storage, we're talking about using the hard drive of a device other than the one that's on your computer, and it's something that you access through that basically usually through that local area network. Let me explain what that means. The computer network for your building, for your company, let's call that your local area network. And so let's say we're in Grice Hall, and we're all in a computer classroom, like Grice Hall 336. That's a real big classroom, but we have about like 40 computers in there. But one of the computers could easily be the place where we store our stuff. Like, where no matter who's doing the work, everybody's stuff is going to be stored on computer 5. That's our storage computer, our file server. That's an example of network storage. As you read in the book, it talks about network attached storage devices, and it talks about storage area networks. A network attached storage device is basically kind of like what I just described, where there's a specific device, and what you see pictured here, this is a network attached storage device. And you can buy these. They're created by companies like D-Link and Belkin, and all the same people that make like networking equipment also have devices like this that they sell. And these things you see right here, these are just hard drives. These are hard drives that snap in there just like a Lego. And then you use software to configure this thing. You connect it to the network, and then everybody on the network can then just save their stuff there. So you've got 25 people in the accounting department. Well, they save all their stuff to this NAS unit, this network attached storage unit, and then you just make sure that you take really good care of this and back this up. And it doesn't matter if she spills a Coke on her machine and it breaks. Well, I mean, that's unfortunate, but the fact that she broke her $300 or $400 computer doesn't matter so much, because all her data is still safe over here at this NAS unit. And so network attached storage devices are becoming very affordable, easy to use, and computer networks are so ubiquitous and so part of everything we do now that they're really becoming something everybody is using like crazy. Now, a storage area network is just basically a network that's been built for the express purpose of storing, letting people store their stuff, and it's connected to the regular network. So it's kind of a if you can remember SAN or NAS, and remember that that's basically a way for you to store your stuff on another computer, I'd be happy with that. That would be fine. But there's a little bit of difference between a NAS and a SAN. And if you get into IT or information technology as your job, then yeah, you'll need to learn those differences and all that sort of stuff. But for regular people, just knowing that a network attached storage or a storage area network, that you use that to store your stuff at some other computer, then that's sufficient. So a related technology is basically this cloud storage, and it's also referred to as online storage. And I have some logos here I'd like to pop up for you. This should help you hopefully remember what cloud storage or online storage is. These are 3 examples of this type of storage technology. Basically, you're using the internet to connect to somebody else's hard drives, such as Google's or Microsoft's or Dropbox's computers to store your stuff. But the same sort of principle, instead of storing things right on your computer, you store it through the internet on either Google's, Microsoft's, or Dropbox's computers. Then they back it up, they take care of it. And so if your computer fails for whatever reason, it's not a big deal. As long as you can get an internet connection on another computer, you can get to your data. So cloud storage can be free. SkyDrive and Google Drive are free. Versions of Dropbox are free. There are certain things you probably wouldn't want to put in cloud storage, especially the free versions of cloud storage anyway. I like to use this example. Think about, let's say you worked at Kentucky Fried Chicken, and you had the secret recipe, the 11 herbs and spices that Colonel Sanders came up with to make that delicious fried chicken. Well, you wouldn't want to store that on Google Drive because, quite frankly, you don't own Google Drive, and that's that's a secret that's critical to the success of your company, right? Of KFC, and so you would want to keep that on your own stuff, and so you might create your own sort of NAS or SAN solution and save that stuff within the company. Store it network-wise within the company, but you wouldn't want to put, mission-critical or secret stuff or confidential stuff in places like Google Drive or SkyDrive or Dropbox necessarily. Now, if you had a paid version where there's some sort of contractual privacy sort of understanding in place, then maybe. But let's say you're an attorney and you have all your privileged information, like you've been writing memorandums and affidavits and subpoenas and all kinds of stuff that have all sorts of privileged information in there. Your work product, you wouldn't want to put that in Google Drive or SkyDrive either. You'd want to store that somewhere secure where no prying eyes could get to it. So you could you still have your privilege. So these are really cool technologies, great way for us to store data, but cloud storage, this free version, is not always appropriate for every bit of data we have. Sometimes you have to keep that private stuff private, and you do that through your own internal network storage. Okay, we're to our last 2 points here, and that's basically at the very end of the chapter. They talk about two ideas, or two ways that you can store data for large computer systems. And one of those is called RAID, and then one of those is magnetic tape. We've already talked about magnetic tape, so we can basically we've already discussed that to a large degree, so I've got like one other thing I'll mention to you on it. But we've covered that for the most part. But we haven't talked about RAID. RAID is an acronym for Redundant Array of Inexpensive Disks. Independent disk. It used to be inexpensive disk, and that's basically changed. But all I want you to take away from this lesson is basically this: if you get into business for yourself, if you become a business owner, or if you become an IT person and you're managing the computer resources for a business, then you want to get familiar with RAID, because on your servers, what you can do is you can take multiple hard drives and configure those to work in such a way that they are safer than just having a single hard drive. In this example, there are different levels of RAID. Basically, RAID goes up through like RAID 5. Just on this graphic right here, I have like RAID 0 and RAID 1 displayed for you, but there are different levels of RAID and different ways to configure it. Let's just talk about like RAID 0 and RAID 1. In this case, in each of these, there are two disks. So that, let's say there's a server and there are two hard drives in it. And in this case, what happens is part of the data is written to disk 1 and part is written to disk 2. And it goes back and forth. And so what happens is if this disk, let's say disk 2, breaks for whatever reason, because it's machinery, sometimes it's just going to wear out. But once disk 2 breaks, what you can do is get a new disk, just put it in there, and then based on how the data has been written to disk 1 and disk 2, the computer can regenerate what was on disk 2 for you. And so you're getting a lot of things here. Basically, you're getting some safety because all of your data is not in one place, and so if that one thing fails, you're not doomed because half of it's also over here and it can rebuild that other half. And also, you're getting to use all of the disk space in the 2. So this is a terabyte drive and that's a terabyte drive, so you're getting like 2 full terabytes of disk space, and it's spread out between the 2. And because it's spreading it out, hopefully it's going to prolong the life of the items as well. That's RAID 0. That's called striping. With RAID 1, it's called mirroring, and that's exactly what it sounds like. Every time it writes something to disk 1, it goes over and writes an exact duplicate to the other disk 2. And so in this case, what's nice is if disk 1 blows up for whatever reason, it just wears out, it can automatically fail over to disk 2 without ever suffering any sort of downtime whatsoever to rebuild another disk. And you just immediately, and then you get another disk, put it in here to replace the broken disk 1, and then it can start to mirror back and forth. And in not too long of a time, you can have a complete mirror over here that mimics what was over on disk 2. These are just strategies for making sure that you don't when something fails, and something will fail. This is machinery and it's going to fail, but this is a way to protect yourself so that you can survive a disaster as well as possible. And again, there's RAID 2, RAID 3, RAID 4, RAID 5 that you could also learn about as well. So this redundant array of independent disks used to be inexpensive disks. These are ways that you can store a lot of data in a safe manner. And then lastly, we've talked about these magnetic disks here, these magnetic tapes, I'm sorry. These are the sequential access things that we talked about. The only thing I want to add to what I've already said about them is that whether it's your backup tapes, and you'll see like there's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, whether it's your backup tapes or whether it's your surveillance tapes or whether they're DVDs or however you're doing your backups, you want to have some sort of rotation in place like this, because and store one of these days off site. So basically on Monday, whoever your IT person is or whoever the person is that if it's even if it's like an office manager that just pops the tapes in there for you every morning, that's part of their routine. Make sure that they're putting a different tape so you've always got a week's worth of data that you could go back to. It's better if you have 2 weeks or 3 weeks worth of tapes that you can go back to. And then like once a week, let's say on Friday or on Monday, they take that tape home with them, or you put it in a fireproof safe. It's better if it's completely off site, because then if there's a flood or a tornado or something, you've got your data stored somewhere off site. We've already kind of talked about that too. So that's the same for your surveillance stuff. Just really prudent things to do with any sort of backup or protective sort of data you're trying to keep track of. And that, my friends, is basically what I wanted to talk about with you from chapter 3. Please remember, you have those additional videos about how hard drives work, how optical drives work, and how DNA is being used to store data. Check those out from the Blackboard site. But I hope you have enjoyed it, and thanks for your time and attention.